Hello everyone, my name is Kla Chakritantitam Thaworn. I am a senior lecturer in software engineering at Monash University. As everyone knows that software defects are very costly and prevalent, but they are very hard to predict and prevent. Thus, practitioners want to find and fix defects as early as possible instead of fixing them in productions. That's why SQA practices like exploratory testing or code review are adopted in many software organizations. But such activities are still very time-consuming and very expensive. So let's imagine that you work at Google with millions of lines of code. You just have no idea which files are likely to be defective in the future. And that's why developers cannot efficiently and effectively find the highest numbers of defects given the limited time and resources. To address this challenge, defect prediction models have been proposed to predict if a file will be defective in the future or not. And traditionally, we often use a historical data from previous releases as a training data to build a defect model. And then we're going to apply the defect models to each file in the current release or a testing data to generate the predictions. And the important factors derived from the defect models also help managers develop better quality improvement plans as well. And finally, the local explanations derived from the model-agnostic techniques like VarImp can also help developers better understand why a file is predicted as defective as well. Surprisingly, we find that the majority of the studies focus on improving the accuracy, while as few as 4% focus on increasing the explainability of the predictions of defect models. So it is possible that the researchers' focus may not truly reflect what do practitioners need. So we set out to investigate the first research question: which goals of the defect prediction models that practitioners consider the most useful? In addition, we also find that different studies also use different techniques which produce different visual explanations. Thus, we also set out to investigate the second research question: which techniques are the most preferred by practitioners? After running a survey with 50 practitioners, in summary, we found that they perceive that the three goals of the defect prediction studies are equally useful. For the IQ tool, which interpretation techniques are most preferred by practitioners, we found that the visual explanations generated by VarImp is the most preferred, while the visual explanations generated by ANOVA and the variable importance is the second most preferred. Now we will discuss the implications of our findings. First, we found that the three goals are well perceived as useful by practitioners. Sadly, our literature analysis shows that researchers mainly focus on improving the accuracy, not the explainability. So, future research should explore how to make software analytics more explainable and actionable. Thus, we would like to call for a new research topic of explainable AI for software engineering. And second, explanations can be also viewed as a non-functional requirement. Sadly, most of the explainable AI tools are developed by AI researchers, not the end users or us. Thus, visual explanations are often not suit practitioners' needs. Future research should also explore how to invent the domain-specific and the human-centric visual explanations that most suit practitioners' needs. Thus, we would like to call for a new research topic of software engineering for explainable AI. So if you would like to learn more about this research area, please visit our book or drop me an email. Thank you.